So today I want to have a look inside this doorbell repeater. This is a fairly old one, and it's not working anymore. I've replaced it with a more modern version of the same thing. But this is kind of an interesting device. So what it has is it has a box which installs inside the door chime, or you can attach it next to it if you won't fit inside. It has 3 leads which connect to the front and rear buzzer and to the ground, if I remember correctly. I think it's actually, anyway, you connect these inside the buzzer. You clip these little leads here. It's a very odd way of doing it, but you clip these little leads to essentially set the channel, or to set what it recognizes. I don't know why they don't use dip switches for that. That would seem to be the obvious way. But you clip those until you aren't interfering with your neighbors. And then you can set the chime it makes by setting these little jumpers in the patterns that are right next to that. So that's the transmitter, and it's driven by the doorbell transformer. The receiver plugs into a wall. You have a volume control, and that's it. This, to give you the model number, I don't know if this is going to be visible on there, but it's Carlon, which is a manufacturer of doorbell stuff, and model RC8253R, made in China. Plug-in chime, a couple of US patent numbers on there, and that sort of thing. On this, you have, if you open this screw up here, you have access to the same set of wires. So this is the radio receiver, this is the transmitter, and I'm not going to make an attempt to repair this. I should say I have had a look in this. This thing was never the most reliable thing, and I bought a inexpensive, not super inexpensive, but different model, Chinese brand manufactured one. It is actually proven to be very reliable and works well. But this older design, I think, is interesting. So let's have a look at the transmitter first and see what we can see in there. I remember when I first got this, this must have been 10 years ago, and I was surprised at this little clip system, and this seemed really kind of old school. Inside, what do we see? Well, we've got a blob, unfortunately, and a couple of 4 transistors, a capacitor. It makes sense, right? Because this isn't going to be energized until the bell is pushed. So I've got a diode, which you would need. So this probably is the power supply circuit over here. I don't know what the transistor is doing. Maybe that's not a transistor. It could be a regulator. There'd be a power supply circuit. Then there's a chip under there. And then this would presumably be the radio circuitry here. Here we have an iron core with a couple of windings over it. That's really interesting. I wonder if that's functioning as the antenna. Let's see if we can find something similar in this one. Apart from that, we've got an inductor here, but there isn't much. A couple of power diodes and a sense diode there, some sort. So, not that much to show, but you can see how this is, right? These just come up and you clip them. But, why wouldn't you just put dip switches on? Cost savings? I mean, this isn't an extremely cheap thing. By the way, I'm wrong about this being the antenna, although this must couple somehow, because that says antenna 1. And we have a piece of wire here. Not really much to the case there. We have the antenna coming up there, and okay, this is not Yeah, so it just comes in on a single conductor here and just ends there. This is only soldered on. You can see there's no trace connected to it, so this isn't. So this is just a little piece of wire, presumably of the correct length, although I would assume that the correct length would go, that this is in fact part of the antenna too, for all practical purposes. So an antenna of, 2, 3.5 inches maybe, 3 inches, something like that. Well, that seems to be what we've got there. Okay, well, let's look inside the receiver. That's going to have some sort of power supply circuit, probably another blob chip, and, a speaker. Oh, take the speaker out. Maybe an amplifier for the speaker. That's a surprisingly nice little speaker. A standard sort of transistor radio cardboard speaker. This is all going to go out, but I'll hold on to that. Okay, well, let's see our board. Okay, this is, what does this do? Okay, I think we can see what that is. That's the antenna. Is it marked? No, but that's got to be the antenna. We have, this hasn't been plugged in for a long time, so we don't have to worry about the dropper capacitor here. So this is using a dropper capacitor to generate the power supply for the circuitry. We've got, essentially it's a radio receiver, right? This is the volume switch, and not really much to say about it. So it's got to have a radio receiver and then a chip which detects, essentially which one of these is clipped. E in the case of both of these, and then uses that to determine what's going on. Everything seems to be working okay here. These are nice and solidly attached. Sometimes when you look in power supplies and things from questionable sources, get concerned about whether the prongs are attached and whether you're going to have to shut off the power at some point to remove a prong from an outlet and hope that your kid is not the one who pulled it out. But so we've got a radio receiver. We've got, can we trace the output? The signal is going to be generated by the chip, right? Because it's going to generate one of these chimes depending on what it receives from the transmitter. And this is different than the current one I have, where you have a button that sets the chime on the receiver, and the transmitter just sends a code which can be paired by pressing a pairing button. So more what we would expect these days in terms of how it works. There's just not much to say about it. It's oh, that's not very nice there. I don't know. Let's see if I can slide a light around a little bit. Or a big solder blob on. Let's see if I can get it underneath. Will it focus on that? If I get my hands away, maybe. I don't think it's actually bridging anything out, but that's not very good. smells, bring it up, sniff, sniff. It smells a bit like old electronics. Okay, let's have a look at the capacitors. Oh, look fine. Nothing looks bad. I do wonder if it's the receiver that failed, not the transmitter. It just doesn't seem like there's that much to the transmitter. And this is only energized, right? So you push the doorbell, this charges up, it goes bonk, sends out its little signal, and then this receives it. This, of course, gets plugged in all the time. It's hot after several years. It's quite possible that something's failed in here. But I mean, not much power. I mean, it doesn't use much power. So, yeah. Anyway, hope you enjoyed having a look inside this. I just find it just astonishing that they've chosen to use these little leads on something like the date on this board is 2005, right? Why wouldn't you put dip switches on it? It's just like, it's bizarre. Anyhow, thanks for watching.